Hi, this video is the introduction of my final project, embedding up to 12 black and white pictures into one picture. First, we load a picture that we want to use as our host image. I always use a dog image, I like it. And when we load it, you will see here are a lot of the red light. That means there is no image has been embedded with any of these embedding algorithm. If there's any image that's embedded by those algorithms, that will be in green. And here we can load the secret image. Here's the window. And let's load the first one. Oh, and by the way, if you do not select them, or if you do not select any secret image, it will automatically choose the first hidden image for you. And now let's try the first one. Okay, here is the result you get. A shortcut I made here is use as host image. When you click it, that embedded image will automatically become the host image, and you can load another image to with the already first embedded image. Let's see. Here you see, here is a green light. That means there's one hidden image is embedded by this algorithm. And let's try another picture. Let's try hidden number 2 and click embed with odd and even green channel embed algorithm and use as host image. Here it is. And also you can use a lot of them. Yes, regardless whatever you click, it will give you the feedback. And finally, if you save the embedded image here, like I will just replace the embedded image here. Now it's a recover time. If as same as the one you can find from the embedding section, you can also load embedded image here. That's the image you want to recover. And as soon as you loaded it, the same thing, the green light means there's a picture being hidden by that algorithm, and red means there's no picture has been embedded by those algorithms. And as soon as you click it, it will give you the black-white picture that you hid. If I was right, they are they're all hidden picture number 2. And if you click those tabs with the red light here, you will get nothing. Those are just not being hidden yet. Another feature that I did here is one click embed all. That means from the first image to the last image, they are all embedded, depends on the order, which means first image embedded by the first algorithm, last image last algorithm, can say. So let's see, embed all, and let's save the embedding image. Similar process, and recover. Let's load that image again, and you will see they are all green now. And let's recover them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. In the next part, I will introduce the code and the software function I used to produce that application. The function that I use a lot is those embedding algorithm. All these functions are about the same, but some tiny difference, like odd and even. I just use that mod to see if it's odd or even, and then is the mod for embedding algorithm. That is when the mod is larger than 2 or smaller than 2, and similar for the mod 8 and mod 16. And the recovery image is about the same, it's just the reverse of the process. And here does contain, I feel I made it too difficult, but since they are all repeated, I don't, basically the idea I used here is I get the embedded image and compare it with the hidden image that I loaded previously. And here is my startup function. For the startup function, I simply just use the dog image as my default image, my hidden one as my secret image, and for recovery as well, dog image for the default recovery image. Here is how my embedding algorithm worked. So first we got the decimal number of each, let's make it simple. So if I got a 4x4 matrix, and we assume this one is a host image, and we have a hidden image that we want to hide, they are all 4x4. In the host image, we will have number from 1 to 255, and for hid image, since we have the flatten function, we can just flat it to 0 or 1. That means we will have this kind of structure here for the hidden image. That's kind of simple. But for the host image, that will be much more complicated. We will have random numbers between 1 to 255, 76, or whatever number it is. What I did here is called least significant bits embedding, and that means so we got 1 to 255. We first transfer that number to binary number. 1 in binary number is 0, 0, 0, 0, 0, 0, 0, 0, 1, and 255 will be 1, 1, 1, 1, and 1, and 1, and 1, and 1 here. What I found here is if we simply change the last digit, which means plus or minus 2 for any kind of number, it does not influence any number at the front. Same reason, if we simply change this number, that is 2 plus or minus 2. Sorry, for this one it should be plus or minus 1. That will not change any number besides this one, this specific digit. That is why all my algorithm does not conflict to each other.